Okay, so for the 2.5 on compound interest, we've been discussing simple interest so far, but then yesterday in our lesson, it came to the point where we were going to start to see compounding semi-annually or quarterly. So what happens is with this compounding, we're having to do the simple interest formula multiple times to see what would happen throughout the year. So rather than repeat that process of doing that simple interest formula multiple times, 2 times, 4 times, 12 times, 365 times, we're going to just use one formula that includes that calculation. So what if it says in your problem that it's annual compounding? Your n is going to equal 1 time per year. Semi-annual would be twice per year. Quarterly compounding would be 4 times per year. Monthly 12, and daily is 365. The most common compounding in your regular banks is going to be daily compounding. So here's the formula we're going to be using. Notice it still has the principal, still has the rate, still has the time. All that's changing is that this is going to have this rate calculation with an n underneath. You'll notice that this looks super familiar to the exponential function I've been having you remember to practice at the beginning of the year, because this is the exponential function you used in Math 1 and Math 2, and now we're doing it with an n that's greater than 1 or different than 1. So step 1, we're going to do insert equation into each of these boxes, and step 2, you're going to show your Desmos work. So Jose opens a saving account with principal of 500 that pays 2% interest compounded quarterly. So quarterly, recall, is going to be an n of 4. What will his end balance be after 1 year? So you go up to the top to insert equation, and it brings up this little box here. And so we're going to say, remember you've got the formula right up here, that the B equals, principal is 500 times 1 plus a rate of 2% divided by 4. There's our quarterly, or over n. And by the way, I think in the insert equation there's a little, I thought it was going to do it with the division symbol, but it's not. Let's go up and grab the fraction. So 0.02 over 4. And can I make this bigger? Way better. And then to the power of, so I go back up here again and find the a to the b, x to the b, and that's to the power of n times t. So it's the number of times it's compounding times our 1 year. The formula goes principal, 1 plus the rate over the n, the number of times we're compounding, to the power of nt. Now we're going to go plug this into Desmos. Go to the scientific calculator and do 500, 1 plus 0.04, divide, 0.02, divided by 4 to the power of 4 times 1, or you could just type in a 4 there. So 510.07. And then we're going to screenshot that on your school Chromebook. That would be a Control-Shift screenshot button, which is above the 6 key. For mine, I'm using a snip tool. For a regular PC, you would be doing print screen button. And for a Mac, you'd be doing command. All right, so there's my Desmos work for my final answer of 510.08. Okay, so now we're going to move a little bit more quickly through these next examples now that you see the process we're using of first inserting the equation and then showing the Desmos work. So I go to insert equation, and I'm going to do the balance equals 1200 times 1 plus 0.017 and this is compounded monthly, so divided by 12 to the power of 12 times 1 year. This is my insert equation work. And I'm going to go into Desmos. 1200, 1 plus 0.071 divided by 12 for compounded monthly to the power of 12 months times 1 year. So here we get 12.20 and 56 cents. I'm going to go snip and copy and paste my work into Desmos. And so my final answer is 12.20 and 56 cents. All right, 1650 for 3 years at a 1% interest compounded daily. What is her ending balance? So let's go 1650 for 3 years, 1% interest. And that was compounded daily. So it's divided by 365 this time. And to the power of 365 times 3 years. We get 1,725 cents.